Good morning, everyone. I want to welcome you to another theory of statistics class. Of course, today's meeting is very, very crucial because of the fact that there's going to be exam on Friday. And I want you to pay attention because I'm actually going to give you information, very vital information about the exam. The exam will be similar to the way the instruction will be very similar to the midterm one. Of course, you are expected to come to the class, to the exam or some minutes to the the start of the exam, and of course you need your scientific calculator because the exam will also test your computational knowledge in addition to theoretical knowledge. And of course, we do not allow graphing calculator. We only allow scientific calculator. Of course, you're going to make it a statistical table, but you do not need to come with one because I'm actually going to attach a statistical table to the exam document. So you do not need to bring any statistical table to this exam. So, like I said, that will be provided. Okay, so let me say this. The exam is, I'm going to start from number one. I can confirm to you in this exam there's going to be a function of the f of xy, could be any function, just like the one you see right now. And of course, a question on conditional function is actually going to be asked. You said that the conditional function of y giving x or x giving y, but I'm very sure probability that a question that look like this is going to be asked is very close to 1. And not only that, I'm also going to ask you conditional expectation. If your conditional function is wrong, of course, the conditional expectation also going to be wrong. So if I were you, make sure you try to just take your time. Okay, take your time. Okay, so in number one, we're going to have 2 questions in number 1, A and B. So I'm confirming to you, you're actually going to be giving a joint distribution for f of xy. They're going to give you a joint function f of xy. And of course, they're going to ask you to figure out the conditional distribution, maybe y giving s or s giving y. And of course, they're also going to ask you about the conditional expectation. Now, that's the way number 1 is going to go in the exam. I can also confirm to you, number 2 in the exam, we focus on univariate function. A univariate function of a continuous type. I'm going to say that again. A univariate function of a continuous type, where they're going to give you f of s, and there's possibility f of s may also contain parameter like theta that is actually going to be treated as a constant. And they're going to ask you to find the expectation of s. Okay, find the expectation of s, find probability. Any probability question can be asked on that as well. So I'm confirming to you, you're actually going to be given a univariate function, and in the univariate function, they're going to ask you to figure out the expectation of s and probability of a particular event, I can assure you that. Then I'm going to go to number 3 now. Number three, I'm actually going to assure that there's going to be a joint table, a joint probability table, and where we're going to ask several questions. Okay, I can ask you covariance, I can ask you correlation. Of course, if I ask you to find the covariance or correlation, there's a lot that needs to be done. You don't just put your answer. If you put your answer like you don't show me how you arrive at that, you only maybe out of 25 points, that person may get 5 points for just providing answer. And that person will lose 20 points. And that's why, if I want to answer a question that has to do with the covariance or correlation, okay, so what I actually need to do is, so four of us write out the formula. I will cherish formula a lot, okay? The strategy is very, very important. So how do you, come across what you get? So if I want to find covariance, or I want to find correlation, let me say if I want to start covariance, I will need to first write the formula. Okay, I will need to write the formula. Now, with this, I know what I'm going to find from the table. So I need the expectation of xy. I need the expectation of s. I need the expectation of y. You have to show all the way you get that. Okay, for discrete, okay, the probability of that equal to that. Okay, so like I said, you need to be able to, write the formula down. Okay, the formula is very, very crucial. Okay, if you take a look at this particular problem, you can see S start from 1 to 3. So here, I'm actually going to say S start from 1 to 3. If I want to get this, Y start from 1 to what? From 0 to 1. Y start from 0 to 1. Y, P, okay, you see the formula? Okay, the formula, you have to state the formula to get a full credit. Okay, so here's summation, okay, xy, the probability of x equal to that, y equal to that, okay, and s start from 1 to 3, y start from 0 to 1, okay. Now, of course, after you're done with that, you plug that in, you get your covariance. And if the question asks about correlation, okay, if the question asks about correlation, of course, it's actually going to be the ratio of the covariance to the square root of the variance of S and the variance of Y. Now, don't forget the variance of S. The variance of S is expectation of S squared minus expectation of S all squared. Don't forget the expectation of S squared in that regard is actually going to be equal to this, where S start from 1 to 3. And of course, the variance of Y equal expectation of Y squared minus expectation of Y, okay, or squared, okay, the expectation of Y squared, summation Y start from 0 to 1, Y squared, the probability of Y equal to that. So I need you to state our formula, okay? Now, you're going to see a question like that, and you can see, you get all of that, then you get your covariance, okay? And if it is correlation, then you actually... Now, I'm going to say this. In question 3, this is just first part in question 3. And I want to tell you the second part in question 3. And I need everyone to listen. Now, I will give you the moment generating function of one of the continuous distribution we've covered in this course. It could be normal, it could be gamma, it could be exponential, it could be beta, one of those four. Okay? 1 gamma, 2 beta, 3 normal, okay, 4 exponential. Okay, I'm actually going to give you the moment generating function of one of these, one out of this, and I will ask you to derive the mean and variance. I'm going to say that again. The third part of the question, the second part, I'm actually going to give you a moment generating function that will be provided, okay? I'm actually going to give you a moment generating function of one of these 4, and I will ask you to derive the mean and variance. But let me tell you this. I'm going to remove this, of course, out of these 3. Of course, you know, here, the moment generating function is actually 1 minus beta t raised to power minus alpha. Here, the moment generating function is exponential raised to power that sigma squared t squared over 2. And here, the moment generating function is actually 1 minus bt raised to power minus 1. Now, I'm going to give you any of these, and I ask you to derive the mean and variance. If you want to derive the mean and variance from any given moment generating function, okay, if you want to derive the mean and variance from any given moment generating function, if you want to derive the mean and variance from any given moment generating function, the mean is actually going to be m prime of x0, which is the same thing as d dt m prime of x of that t equal to 0. That is how to get the mean, okay? So you're actually going to perform a derivative on the moment generating function, and after performing the derivative, you're doing the derivative with respect to t. And after performing the derivative, you're actually going to set your t to be 0. And when you set your t to the 0, then that gives you the mean of that distribution. If you want to find to find the variance, you first need this guy. It means you're actually going to do prime s of 0. I'm actually going to have the t squared of mx of t, where t equal to 0. So when you differentiate first time, second time, and you plug in t to be equal to 0, you have expected value of s squared. And the moment you have the expected value of s squared, the variance of s is actually going to be expectation of s, minus the square of all of that. Why can't you try, why can't you practice that? I'm confident, even though I did not include that in this practice question, but I'm telling you the second part of question 3, we actually give you any of that, and I will ask you to figure how the mean and the variance, okay, from the moment generating function. And lastly in the exam, similar to what we've done in the class, I think I also gave assignment on this. Okay, there's going to be a question on bivariate normal distribution. Okay, and this will involve the use of a table. Take a look at this example. Let me make a projection now. So that everybody can see. Okay, so I need you to pay attention to what I'm displaying right now. Let X be a student math test score and Y be the verbal test score. Okay, assuming X and Y is jointly normal weight. They gave you the mean of the math test score. They gave you the variance, and they also gave the mean of the verbal test score with the variance, and they gave you a correlation value. So which means the two score varies together. You can see the correlation exists. That is 0.60. Now, let me tell you this. In question 4, there will be, you're actually going to have two parts. The first part may four of us ask about, this. Please pay attention. The first part of the question, if you take a look at this, there's going to be one part is going to focus on what is the probability of this. The first question is not going to be conditional. What is second question is actually going to be conditional. Okay, so y 75 giving s equal to 80. Take a look at it too. In question 4, you're actually going to be giving two different. The first one is the unconditional one, and the first one will be conditional one. If I want to figure out the unconditional one, okay, how we need to standardize. If I want to standardize what I have here, okay, I'm actually going to have, of course, you know what we normally do. Z will be y minus the mean of y divided by the standard deviation of y. Okay, y minus the mean of y divided by the standard deviation of y. So 60 minus, what was the mean given? The mean given here is 70. Can you see that? The mean, for y. The mean given for y is 65. Okay, the mean given for y is 65. Divided by, what is the standard deviation for y? You're giving 8 squared, that would be 8. Okay, line between z, line between 75 minus 65 divided by 8. Okay, now whatever you get here and whatever you get here, okay, maybe I'm just assuming. Okay, if this is A and this is B, I'm just assuming, you use your calculator, okay, I'm actually going to have this probability of z less than whatever you get here minus the probability of z less than whatever you get here. So this is going to be, you're going to check the two from the table. Okay, like I said, the statistical table will be provided. You check the two from the table, you subtract, then you get your result. It's very easy to navigate on conditional probability involving normal distribution. Because I told you the other time, normal distribution facilitates, normality facilitates standardization. And standardization will facilitate the use of z-score. Okay, so if I now want to, on the other one, if I want to answer the next question, please pay attention. If I want to answer the next question, okay, so what I'm actually going to do is, I still want to find this, but condition on x equal to 80. Now, here I use unconditional mean, unconditional standard deviation. Then if I want to answer this question, this is no longer appropriate. So instead of unconditional mean and unconditional standard deviation, I'm actually going to use conditional mean and conditional standard deviation. Now, if I actually, for conditional mean now, which is expected value of y given s. Okay, you remember what I gave you before? Expected value of that. So it's actually going to be, I'm actually going to have mu y, okay, mu y plus rho of the sigma y over sigma s, okay, x minus mu x. Okay, now this is the formula for conditional mean. This is conditional mean of y given s. We also have conditional mean of s given y. But right now, because this is focusing on y given s, so that's why I need the conditional mean of y given s. So right now, all what I just need to do, they're giving you the mean of y. You're actually going to go into what you're giving. That was 65. The mean of y is 65. Okay, plus the rho, the correlation given is 0.60. Then the ratio of the standard deviation, okay, so it's going to be 8 over 10, right? 8 over 10. And here, x equal to 80. Okay, x equal to 80 minus the mean of s. The mean of s, oh my God, the mean of s is 70. Okay, I'm actually going to put 70. Take a look at that. Now, let me tell you this. The only condition under which conditional mean and unconditional mean will be the same is when the rho is 0. But rho is not 0. So I'm actually going to compute this and add to 65. And that is going to be my conditional mean. Now, I also need the conditional variance. Okay, the conditional variance, because I'm talking about conditional mean of y given s. I'm also going to talk about conditional variance of y given s. Okay, and of course, that is going to be sigma square y, 1 minus rho squared. And of course, when the rho equal to 0, the conditional variance become unconditional. So right now, so the variance of y given is 8 squared. 8 squared is 64, right? So that 1 minus 0.60 squared. So whatever you get here is the conditional variance. Now, if you now want to solve the problem now, okay, to solve the problem now, so what you're going to do, so I'm going to say the probability of 60 less than y less than 75 giving s equal to 80, okay, is now going to be equal to, okay, so here now, okay, 60 minus, okay, whatever you get in the conditional mean. Maybe I should write, okay, whatever you get here divided by, okay, whatever you get here, the square root of the variance of whatever you get, because the square root of that guy is going to be this conditional standard deviation. Okay, so here, less than z, less than 75, less than 75 minus the expectation of y given that divided by the square root of that. Okay, and in the end, whatever you get, maybe this is A, this is B. I'm just assuming you're going to get a value. Then I'm actually going to say the probability of S less than B is minus the probability of S less than A. Or, go to statistical table. Okay, use statistical table for the rest. There's going to be 4 questions in the exam. Each worth 25 points. Of course, 25 times 4 is actually 100. Okay, it's actually 100. So we started strongly in this class, and I want us to, to finish strongly. And the only condition to finish strongly is actually to pay attention to all what I've reviewed. I'm never going to go outside what I've reviewed for the main exam on Friday. You have the opportunity to score another 100% on this exam. All what you just need to do is to take your time. Take your time and believe you can do it. Okay? Take your time and believe you can do it. Let me tell you this. Preparation for adversity, according to a philosopher, he said, and I quote, preparation for adversity is the best way to prosperity. Okay, preparation for adversity. Adversity is the best way to prosperity. Is the best way to prosperity. Okay? Preparation for adversity is the best way to prosperity. What is the adversity? The adversity here is the hurdle. The hurdle. The hurdle here is, the difficult, some equations or some formula that you need to be able to navigate. If you spend your time focusing on that, focusing on what I've done, then you are prepared for the adversity. And the moment we're prepared for adversity, that is the best way to prosperity. Just like what I used to tell people around me and what I used to tell my children, my 5 girls, okay, what I used to tell them is that, you begin to solve problem before problem arrive. Be imagine there's going to be a problem. And when I was telling them that they're going to question me, Dad, why do you say I should be envisaging for a problem? I said, even though I don't pray for problem to come, but we live in a stochastic environment where things are not going to be the same, because when things stay the same, why are we studying statistics? Why do we study economics? Why do we do science? Because if things stay the same, there's nothing to worry about. If the same thing happens in different days, there's nothing to worry about. Why do we get worried? We get worried because different things happen in different days. I don't know why it happened, but I know they will surely happen. But when they happen, what we should do, we don't wait until they happen. We get prepared. Even though we don't pray for them to happen, but when they do, get prepared. Okay? It is very possible to score 100% or true. Imagine at the end of the day in this class and everybody has A. If everybody has A, I'm actually going to throw a party. Because you can get A, you have 100% to yourself. If somebody lose point out of the 100, another person is not going to get down that part of your point that you lose. You've lost that point forever. And that's why I don't want you to lose any point. It's your point. You deserve to have the full point. And all what you need to do is get prepared. Okay? I've already reviewed all this. You have a race against time. You need to be accurate. And at the same time, you need to finish on time. So what I'm going to advise that you should do, take your time. Write exam before exam. I used to do that when I was in college. I write exam before exam. I give myself self-examination. I normally subject myself to standard examination condition. I'm not going to deceive myself. I'm going to grade myself. When I'm grading myself, I'm not going to deceive myself. If I actually pass the self-exam with confidence, I'm going to go to the real exam with confidence. Somebody who wins a battle doesn't win that battle in the day of battle. That person already won the battle during the training. So I wanted to win the battle during the training before even coming to the exam. And when you have done everything that you are supposed to do, make sure you have a belief that you're going to succeed. If you don't have a belief that you're going to succeed, there's going to be an issue succeeding. I faced a difficult things in my life when I was in Africa, but what kept me going was the belief that I had, that I will, against all odds. Okay, I recognize that there's going to be a problem, but you know what I used to tell the problem? I will figure you out. But it's going to take my time to figure a problem out. It requires, confidence. It requires perseverance. It requires endurance. Because I remember my friend in economics is going to say those who will get the resources are those who can stand for a very long time on a queue. You know, imagine we're queuing for resources and I've been waiting forever and I just queued. I will never get that resources. So it requires a manifestation of the highest level of perseverance. If you are solving a problem and you don't get it, continue solving it. You're still gonna get it. Don't lose up. Don't give up. You are smart. You don't know. You don't realize you are smart. You are smart. Everyone is unique. The only thing you just need to do is just find out. Get your weak point. Moving forward, I need to, four of us, get my weak point. What is my weak point? Oh, this is my weak point. Oh, okay, then I will figure you out. But if you have not identified your weak point, there's going to be an issue. And that is the reason why it's going to look as if somebody is not turning in a very good grade. You have the ability, you have the potentiality to turn in an excellent grade. Don't listen to those who have taken theory or statistics class before, or maybe they didn't end well. Don't listen to them. If anybody has been doing that in the past and they are not getting A, you tell yourself, I'm going to get A. Or what I just need to do, I need to review what the professor said in class. Try to review that, take my time, come to the exam with confidence. Just going to figure it out. A philosopher said, and I quote, the road to success is very narrow. Everybody in the world want to pass through the narrow way. But going by the accommodating capacity of the road cannot take everybody at a time. There's a lot of people in this world. But you know what my friend said? He said, but the road will step aside. He said, everyone in the world will step aside for a man or woman who knows where he's going. Even though we're all going on the same narrow path, but if you are determined, if you are fully determined, they're going to say, okay, they're going to wait for you and say, you go. They will step aside for you to go. Make every other person in the world step aside for you to go. That is when you are fully determined. When you're fully determined, you get things done. Oh, I need some knowledge of derivative in this class. I need some knowledge of calculus, basic calculus. Okay, then maybe if I don't understand right now, I need somebody to explain that to me because I want to do well. If you are struggling with calculus, you are struggling in derivative and antiderivative, meet with me during my office hour. Of course, my office hour is conducted remotely. It's conducted on Zoom. You can be anywhere in the world to join my office hour. Believe you can succeed. Believe you can actually get A. Never rule out yourself of any situation. Don't rule out yourself. Always give yourself 100% chance. I can do it. Even though it may be difficult, but I'm actually going to do it. I don't promise anybody it's not going to be difficult. I don't promise my children life is not going to be difficult, but you can do it. One of my children that is doing track, also doing a PSEO program, I normally subject her to a lot of things. Even before getting to the high school, walk her through some advanced maths, and he's going to say, oh, my daddy, you're stressing me. What's going on here? But do you know what happened? Last week, she now started getting offers. She gets full ride scholarship from 3 universities. And she now came to me and said, Daddy, thank you so much. I said, can you see now? In life, no pain, no gain. I wish you the best of luck. That's all I got for you today.